You are able to see the screen, right?
Yeah, we can see it.
Okay. Well, hello everyone. I select the topic hybrid serverless computing opportunities and challenges. This is a paper of about 31, 35 pages. It was kind of long and difficult to understand, but I tried to summarize, and I hope you enjoy it. Well, first, when we talk about hybrid, first we need to understand again the serverless, and as we know, serverless computing is still largely limited to applications running on a single provider's platform. We have discussed that all over the lectures. And also, as you know, serverless platforms arrives like less than a decade after the public clouds. So we can see it. We can see serverless as an extension, sorry, and it's focused on simplicity, scalability, the pay-per-use with no little or no knowledge of cloud servers. And also, as we have read and we have discussed, the cloud computing has evolved from running an application on single public clouds providers. And what the authors mention is that we should move that, or we should focus on hybrid environments in multiple private clouds. So, well, with the hybrid cloud environment, well, we should be productive, and also we should see that the hybrid is focused on working with public clouds, private clouds, and also focus on a natural step in the evolution that includes IoT, edge platforms, and also our personal computing devices. So, well, the authors mention their own definition of what is an hybrid cloud, and I will just read them. Well, the author's definition is hybrid cloud in the broadest sense, encompassing public clouds, on-premise data centers, and edge services. And well, in the paper, the authors also mention the definition from IBM and Microsoft. So IBM says that hybrid cloud combines and unifies public cloud, private cloud, and on-premise infrastructure to create a single flexible cost-optimal IT infrastructure. And well, Microsoft says that it's a computing environment that combines also an on-premise data center that we call private clouds with a public cloud, allowing the data and applications to be shared between them. So, well, during this presentation, maybe you will hear about the public cloud, a private cloud, and IoT devices, and this stuff. It's kind of related. And well, in the paper and small research that I did, this is the relation again between the public, private cloud, and multi-cloud and hybrid cloud. So this is the idea. The author says that right now we are kind of in the hybrid cloud. So it's more like, okay, we are working on private clouds right now, but the idea is to combine them with the public, and also are more resources such as edge computing. And something interesting that I found during uh, while reading the paper is that they mention um, that the popularity of the serverless computing against hybrid cloud in the last 15 years. So even though the definitions of hybrid cloud are evolving and there are multiple ideas, uh, I haven't heard of this. So until I read it. So the future is that we can see that this area is gaining popularity alongside the serverless computing. I researched a little bit about this. The authors have a picture like the one I showed you, but it was from 2 or 3 years ago. So I said, okay, I will research again. And on their image, serverless computing was a more interesting topic for people in general. But now hybrid cloud is well, people is looking more for hybrid cloud, sorry. So it's kind of interesting. I was about to show you both images, but I said, I think we should have the newest. So it's something that many companies are working now. Well, I continue. With the hybrid serverless computing, we have 5 main features. As we know, the serverless focus on reducing the complexity and allows the use of computing resources while providing an ideal development platform that, that this is a distributed hybrid cloud platform. And also, what I understand is that the largest benefit to developers' productivity, it's about this, mm, it's about the developers can the interface, yeah, the different interfaces we find in the cloud is just about programming or developing, but also it requires well, minimal configuration to comfort the system limits or the system defined limits that exist. And with serverless computing, however, it's still in its infancy, with most serverless applications developed for a run or on a single serverless platform. So there's a lot of things to continue working. And well, I would jump to the different benefits of hybrid serverless. And well, first, the hybrid serverless architecture brings some benefits to developers and the different platform providers. First, well, the developers normally benefit from the flexibility to migrate the serverless applications to different platform vendors. And well, the idea is to take advantage of pricing differences. Some colleagues from the class has explained their situation with the company sometimes. Well, the choice of a vendor is not a one-time decision, since the application may have different load patterns as our application evolves, and different vendors normally offer pricing plans for the different work cases or the different use cases. And well, with our second point, it's like developers for sure need flexibility to migrate vendors as the requirements evolve. Some applications require non-functional guarantees, or they require different platform services as our application matures from proof of concepts to proof of concepts to a popular production application. And I think we all of us deal with this every day. That sometimes we need to develop a proof of concept, but then we need to do everything again because we need to well, not everything, but maybe the most important features we need to reward with them. And so because we need them for production application. And well, the hybrid architecture facilitates the deployment from the different choices for proportion of application. So a related point is that the developers want to deploy the different portions of applications to the edge and improve the user latency, but especially I think in big companies. And the idea is sometimes is to combine with virtual machines and use the serverless based resources for the application execution. So with this, we can say that the developers sometimes may have constraints on parts that their application can be deployed. And for example, I found this example interesting with the health records. As we know, with the health records, there may be regulations that the government uh, says, oh, you should store in a specific cloud or network, you will have it in a specific place. So the idea is to have this can manage this kind of information in the most secure way. But you need to look for the best data center that manages, and sometimes there are the big companies. So maybe there we should give the opportunity to small vendors. And well, with the last um uh, benefit, it's that another developer is the is the ability to mix and match the different services provided by the different vendors, rather than make the choice to deploy the entire application on a single platform. Um, and the authors give an example that says that the idea is to choose, for example, you choose a fast platform of one vendor, and then you want a login service from another vendor, and the messaging services for another one, so you can combine all of them. And it sounds interesting. I don't know if it's but I don't understand if it will help or not, but I found it's a great idea. Well, also when we have benefits, so for sure we have roadblocks with hybrid serverless computing. Well, uh, with the hybrid serverless computing, it extends to the hybrid cloud and include all the different computing paradigms unified. And the idea is to use to have standards or compiler based approach. Right now, there are as far as I know, there are not a lot of standards. So, well, with the Roblox, we can find that the most serverless applications today use the services of a single vendor, what I mentioned at the beginning. And well, we can say that this is because of the ease of use, the different performance benefits of using uh, a one vendor's ecosystem. Then we can say, okay, the serverless platforms today need to offer a web of services that the developers for sure may need. And the idea is to making the different hybrid architecture more developer friendly. And this, with this idea, is to give an opportunity to smaller vendors to offer specialized services without having um, to replicate the complete stack of services needed for an enterprise serverless application. And what the authors mentioned, and I found interesting that with Roblox is that there is a need to address the impedance mismatch when you reach across different serverless platforms from multiple providers. And they mentioned that sometimes the different properties that most of the companies or some developers try to focus is with topics such as latency, scalability, the availability, and for companies, for sure, the cost. And well, with these ideas, there are also functional mismatches, such as the different security policies. Authors mentioned the messaging semantics that they need to be considered to assess this problem. And also with the different opportunities and challenges. Well, this is kind of long. Okay. Well, first, they say that they should be standards, and we should look for a degree that there should be standards used by the different by hybrid serverless computing. Also, authors mentioned the interfaces description. There should They said that there should be a functional specification like input and output parameters, what happened with the non-functional ones, and the and they mentioned also the cost for invocation and response time estimates. Well, it sounds really interesting. Then they mentioned the container adaptation, and they have a question that says, can containers be adapted to run in all possible computing environments? And they said, okay, use the public cloud and edge services while using the IoT devices? It's like an interesting question. Then they also mentioned the container orchestration. Um, they said that here with containers, there's a challenge with security uh, when when it's compared with the different virtual machines, and that this problem with containers should be addressed. So in the long term, because there should be kind of some problems. Then they also mentioned the compiler optimization, and they said, okay, we try to get the idea that how the compiler optimizes the selection of the different service based on the application requirements. Sometimes this is kind of tricky because some requirements are ambiguous, so we don't have a general idea until we face that or until it's presented to a client, something like that. And well, finally, they mentioned the developer experience. This it's like we mentioned the tooling of productivity, and they mentioned some specific points like okay, their cost of different running containers with 1 GB of memory uh, can be less than 1 cent of dollar each hour, or they look for that in the future. That's the idea they give for the future, but they know that to have just one cost is unlikely to change, which is developer time per hour. And also, and I think that's a small conclusion, we can say that it is important for the hybrid serverless computing and its future to try to support the developer experience regardless where containers are running. It can be local, remote, using cloud or the edge. But it should be the idea is to use or run identical code, the same code, and use the same tools. And with this, we should say that there should be a standard that can be consistent, and it gives a better remote experience. And the authors said a good word that you can call it the transparency, and also to be able to observe everything and have better they call it the buggability skills. So it's kind of interesting. And well, um, for this future and this small conclusion, I close with a picture that the authors at the end of the paper, I remember, they said something like, hey, in the 1970, we just have internet. By 2000, we have mobile and web applications. 2020, or you can call it our present, the hybrid computing, there exists the serverless, the edge, or an IoT devices. As we know, all of these, if we have all of these devices, there are billions and billions of devices. So we have a lot of things to process and understand. And then they said that finally by the 2050, the idea is to have as hybrid serverless computing as a whole. And well, that could be a great future, and I think that could give us opportunities in the job market. And well, that's all from my side. I was running, but okay, I try to give a general idea of hybrid serverless computing. Thank you.
Okay, thank you so much, Brian, for presentation and keeping it exactly on time. So you stop sharing. Actually, I wanted to
Sorry.
go back to that definition of because just in this photo, that last photo that you had, okay, either one.
The next one.
Okay, this one. So basically, they are defining the hybrid cloud as like this, right? But in
Yeah.
the last photo, they are saying a hybrid serverless that include everything, right?
Yeah, their idea is, well, they show examples of how it worked, but to be honest, I didn't understand at all. So I said, okay, it would be difficult for me to explain that. But they have small examples like, okay, I want to use this service from one provider, and then I will join them. I will have a second one that is public because maybe it's expensive service. Okay, I would use them. And then, okay, what else do I need? Okay, I need a tier stage. So they use a tier vendor, and they combine like 6 different vendors that I think for billing and that kind of stuff can be complicated. But it seems like it's good, especially for people that don't have enough money or small companies that don't have enough money. They can use different services. And I think that that's cool.
Yeah, okay. Got it somehow. But it's still, I mean, anyway, it's not your problem. I mean, the figure is a little bit confusing. I'm trying to figure out what exactly they are defining. Basically, hybrid serverless computing that include everything IoT, edge, serverless, hybrid cloud, hybrid computing.
Yeah, it's a little confusing. I am the discussion leader, and I also read this paper. But what they refer to as hybrid serverless computing is that they focus mainly in different CSPs where you can choose only one, and you run your applications in that CSP, but you can't do or run applications across multiple CSPs, like and in an well, I would like to avoid the discussion with some questions, but they're talking about like
Yeah, go ahead, Paul. I was
different,
just trying to start it.
yeah, to understand what is like hybrid. Yeah.
Just to complement what Paul and Brian said, I would say that hybrid serverless computing and 2050 means that they are gonna, well, they are not, they are going, don't go, they are not going to be barriers between the public cloud and the edge, because nowadays the challenge for the hybrid cloud vendors is to provide the efficiency to the customers to move from one cloud to another. They are trying to have these movements without the perception. They are now in maybe in Google, sorry, in maybe Microsoft, and then in the our Amazon Web Service, and the one they have. I guess that's what it's the meaning of the last chart, the hybrid serverless computing. There are not going to be barriers among the hybrid, well, the private and the public clouds.
Okay. Well, I'll continue with the questions so we can keep forward. Let me check. Where? Okay, I moved from my. The thing here is that there is not interoperability among CSPs, as I said. What are your ideas for serverless cloud computing to happen? I mean, of course, I'm thinking about some kind of standardization, so they can share some resources for this to happen. Or what else? Or what do you think that this? Which factors needs to take into account for this to happen?
I think the most important one for us to really start experiencing like hybrid serverless is to have SDKs or development kits that are platform agnostic, right? In the sense that, I mean, we just need to turn off a couple of switches and you are either in GCP or in AWS or in Azure. But at the end, the templates or whatever language or standard that is in front of all of these serverless stack remains the same. I mean, that's what I think that is actually limiting interoperability, right? Because most of the deployments are now being done somehow via code, right? I mean, like Terraform is in there, but it manages like infrastructure, but there's no like really serverless management, right?
Yes. Yes, and serverless is broader than that. This is like an idea only. What I understood from the paper. They're trying to figure out what this is about. Yeah.
But something Gautier said about cloud providers facilitating this shift between service providers, facilitating shifting, or as Rodrigo was saying, being agnostic about which one you're using. But is that, I mean, based on the experience of all the class you're working in the industry, is that really something that's going to happen, or do we have samples of that in other industries? Because usually companies make barriers, right, to make it hard for you to shift or to switch basically from the company to another company. So I'm trying to think if that happened in like historically in other forms to see what's going to happen in like future or near future. I don't know if you guys have any idea.
Well, just recently, I've been working a lot with this tool that I can share. This is serverless, the serverless framework. And this serverless framework allows you to keep one same template for multiple cloud providers, even them being AWS, Azure, and there has been tons of support for this kind of like initiatives. Yeah, it has been working nicely. I mean, we have this in production as of right now. So yeah, there is a clear advantage. As of really us exploiting that, that's a big difference. Because, and it's not because we know that there are any better, but because there's a lot of cost involved in managing multiple platforms. I mean, we can barely keep one of the like eyes on one of the accounts. Keeping an eye on multiple accounts at the same time is just, I mean, it's always something that can be covered with more people, but at least that's one of the main reasons why we don't have this hybrid mix and match approach.
Anything? Anyone else? Okay, let's move. A question that I have is in a utopian world where we can, let's say that we take advantage the positive factors that the CSPs offer. I don't know, maybe Amazon Web Services offers advantages from on Azure, and in an utopic world where you can choose the functions that that are better for your service, and this interoperability will make the service usage cheaper. True or false?
I don't know. It's like,
tricky. It's kind of tricky because
yeah, I mean, because there is always, this can be good, right? In the sense that they can have like, okay, like limited offer just for these 3 days, you can go on and use a server for half the price. And then you can like take advantage on that kind of stuff and go on and for those 3 days, really take advantage. but you have the certainty that you can always go back to your traditional stack and things will still continue working as they're supposed to, right? But I don't know. I mean, I don't think we are, I think we are very far away from that.
Because they're here for the business, not for not for the other way around.
Yeah, it's a way for them to, I mean, if the interoperability stack gets so good at some given point that cloud providers need to find a way to keep you attracted to them, even for a limited time, right? Saying like, okay, we have an offer for X amount of time, just for 4 days of database, you can get this much, right?
Mhm.
But I don't know, it's,
Yeah.
I think that we will have in the future more resources and with an standard for sure. It's an utopian word. We can have like, okay, more resources from open source. Open source. And if you have a company and you try to develop something, maybe, well, you said, okay, I have this from free for open source. Can you help me to move to I don't know, to a level and enterprise level? But you have a base, they can help you just with the more things that are specific from the big providers. I don't know, with security and stuff like that. They can help you to assess a specific problem. But I'm not sure how it will work.
Yeah. Anyone else? Okay.
Yeah, I don't think that, well, I don't know, but based on what Madi said, I think it is kind of, as you mentioned as well, like utopic to think that maybe all the cloud providers are going to like work in something common that like to help to like integrate all the clouds. I think, well, yeah, they are competing between them, between each other, like to get you like to use their services, right? And creating something so that you to be able to share between to jump between clouds. I think it is kind of like counterintuitive. I don't know. I think what we can see is maybe there are companies like Terraform that create something in the middle, but I don't think that the big cloud providers are going to work in something in SDK so that you can develop for any cloud, I guess. I think they will be always there will be all third-party companies are going to be like the ones in the middle, and all the big players, cloud provider players, are going to be always like, if you want to use my stuff, then you need to learn my my languages, right? My technologies.
Mm-hmm.
So yeah, I don't think this will bring prices down, honestly.
Yeah, prices is one thing, and another thing is companies that I don't know. For example, all the time, for example, Apple case comes to my mind, like how they are making, how they are basically locking users in their how to say, in their ecosystem, basically, right? It's ecosystem of operating system, hardware, everything. Like basically, when your user get in, use their system for a year or two, you're kind of really locked up. I mean, you can go out, but you lose a lot of things, a lot of benefits. So I think, as Luis is saying, I mean, that's a good thing actually for customers, because the competition bring the price down at the end. It's a good things that benefits users to some extent, but I mean, benefit them in the terms of prices, but make it harder for them to switch if they change their mind. So I think maybe it's the same thing with the case with cloud providers, because everything is so interconnected. You can swiftly shift from one to another without any cost, without any problem or hassle. Then the competition may lose the concept. I don't know. I mean, I'm trying to just wrap my head around to understand.
Okay. And third question is, in a simple way of thinking, we have, let's say, problems of interoperability because there will happen. Such as cold starts among the CSPs. You are working on a service and you need to do a transaction with another, but it's in a cold start status. What other problems can you cite that will pop up with this kind of interoperability between CSPs? Did I explain myself? Yes.
I didn't get it well, your question. personally.
Because when you work with two different CSPs, vendors, Amazon, Azure, Alibaba, you have a service established, and you, let's say we have this interoperability within CSPs, but you make a request that includes the other CSP, and we have the cold starts, right? And that will delay the request, the answer. And this is one problem of too many, I think. What others do you think about that will happen?
There could be like latency between cloud service providers, right? I mean, one of your cloud service provider could be near, but the other could be really far, and having some issues like in the application, some timeouts and stuff like that.
Yeah.
Mhm.
One thing that would really contribute to latency is that, at least from the stacks that I have worked on, we do exploit a lot things being on the same like virtual private network. So if we have like multiple clouds talking to each others, it does bring, other than the latency, the security, right? Because inside of the virtual like private cloud, you can make sacrifices like not changing machine to machine tokens and stuff like that. But outside of it, you need to have like end-to-end security all the time. So you need to be like more aware of those possible issues.
Mhm. Just to mention a few of them. This sounds like some kind of utopian utopic, because it's like synchronizing all the lights in the city.
Yeah. Why having compatibility with multiple cloud providers and not only have one big cloud provider, right? I mean, it's like,
Yeah.
like basically this will be equivalent.
Yeah, the authors mentioned that there should be some kind of compilers, standardized compilers, and that kind of details that for that to happen. It seems very difficult, but okay.
I mean, the business side of it is like what they are doing nowadays with streaming services, that they're providing a lot of bundles, right?
Yeah.
Because the competition is so high that there is there's not enough people, right? So
Yeah.
what they do, they bundle, like they offer you HBO, I don't know, whatever, Paramount. In this one bundle, right? You're using basically, for example, Amazon Prime, but you have access to Prime Video, you have access to Paramount, you have access to HBO, you have access to, I don't know, maybe certain things can happen in the future with cloud providers.
Yeah, I mean, interoperability in streaming services will be like, I want to watch something. This
Yeah,
is
I don't care where it's.
Yeah, just take me there, and I don't need like a full subscription. Just for this time, I need a subscription. Get me going, then return me because I'm watching anything.
Then how they deal the price and pricing is between them, right? let them handle the pricing, who am I paying for, how many percent goes to Paramount, how many goes to HBO. It's not my problem, right? I just want to whatever I want.
Somehow the model that Spotify is using, that they pay for the artist, but they will be paying to the streaming services vendors. Okay. Well, that's all from my side. I don't know. Any final comments?
Okay. Thank you so much,
you.
Brian, Paul, for handling the discussion. We are basically actually right on time to move to the next presentation. I think it's Rodrigo, it's you, right? Next.
Yeah, that's fine. So let me share my screen. Here. Are you already seeing the presentation?
Yeah.
Yeah, okay. Okay, then. I'll go a little fast, sorry, because this is like, I want to have respect for everyone's time, and this paper was a little bit more complicated than I expected, so I also removed a lot of the important parts. Sorry for that. And if you want more details, you can ask me whatever you need, or there's also the paper. So this is about CloudBurst. That is a stateful functions as a service. And I'll explain every single part of this terminology. Just a second. So first, we'll talk about what is the difference between this stateless and the stateful serverless. So first, we need to understand what has facilitated the function as a service paradigm. And this is disaggregation. The disaggregation of the cube, the compute, and the storage services is what has allowed auto-scaling of serverless platform. And how does disaggregation looks like? Basically, the computer layer on one end quickly allocates resources according to the workload. And for the storage, we usually keep a shared object or key values stores. And current function as a service platforms take this disaggregation to an extreme. And this means high latency, weak data consistency guarantees, also that there is no point-to-point network communication between functions, and there is a lot of very slow nested function calls. And they get in this paper to the conclusion that fast platforms work well for isolated stateless functions. And therefore, they talk about a way to bring stateful serverless into reality. And to make this occur, they talk about LDPC. That is basically logical disaggregation with physical collocation. And what does this imply? This implies deploying services, resources, and also hot function data physically nearby. This is very important. While at the same time allowing updates at any function invocation site. This will become more understandable in just in the following slides. And also keeping wire speed cross-function communication. This means like no overhead of other frameworks and stuff like that. And to implement this LDPC, we need a key value store that has low latency, that is able to auto scale. And also we need a version of this KVS cache on every machine that hosts functions invocations. Now, well, this is like the overall concept. This is not like the actual implementation. CloudBurst is the implementation. This is LDPC applied. And what is like their main claim? That they have they do care a lot about consistency. And to implement this consistency and to implement also the LDPC, they use Anna, a database framework, for this key value storage. Why? Because it has the expected low latency, auto scaling, and most importantly, the coordination-free consistency level and these mergeable monotonic lattice data structures that I don't talk much because they are like another topic. And also to implement CloudBurst, other than Anna, they also use protocols to guarantee consistency and tons of caches. And they at the end like get to this conclusion that is very important. So I added it in this like smaller diagram. That is that distributed mutable caches introduce the risk of inconsistencies. So basically, if we keep these caches for stateful functions, this brings some risks. And in this scenario, the strong consistency across caches via quorum consensus, for example, through Paxos, don't really work, especially because of the auto-scaling part. And therefore, we need to look for free of coordination approaches to consistency that are a better fit for all these serverless platform, especially because of the autoscaling part. And well, this is all like the big components, just like an overview. And now we can really look into the architecture, like the physical parts. So we have first the cloud load balancer, that is like a standard stateless load balancer. We have function schedulers that receive requests and request them to and then forwards them into executors. These executors are run in individual processes that are packed into virtual machines along with a local cache, which is this one. The local cache works simply as an intermediate between local executors that are these and the remote key value system that is ANA. And ANA, other than the data, it also keeps system metadata. And this system metadata is important because it helps provide auto-scaling and fault tolerance. So yeah, up to this point, we have gone into first, stateless is the current paradigm. We are trying to introduce stateful. Stateful requires LDPC. Cloudburst implements LDPC through ANA, through caches, and through some protocols that I am going to talk about. One of the most important topics from all of this proposal is consistency and the consistency guarantees that they allow in their system in Cloudburst. So I will just dedicate this entire section into the consistency claims they make and how they manage to guarantee these consistency levels. So first, cache consistency. So for Cloudburst, the composition of functions is represented as a directed acyclic graph. And this one serves as the session, also known as the scope of consistency. And all the reads and writes that occur in a session happen to experience the same chosen definition of consistency. And this directed acyclic graph, the functions that are in this graph can run on different executors. And therefore, executors must provide consistency across different physical machines. And to have this occur, they use distributed session protocols. This is an example of a directed acyclic graph in which you can see it's a representation of this kind of dependency, right? And the big idea is that we can have each one of these nodes being executed in different places, even though they belong to an overall bigger function, right? And to achieve this is why cache is so important. And also that there are certain levels of consistency experienced by each one of the executions occurring in these nodes. So yeah, we talked about this one, the chosen definition of consistency, and which definition of consistency does Cloudburst provide? It's repeatable read consistency and causal consistency. Repeatable read, this is more or less copy paste from the paper. Sorry for this, but this is this is very important. This can be paraphrased that much. That basically it says this level of consistency in a linear DAG, where is when any function that reads a key k either sees the most recent update to k, or if there is no most recent, then it sees the first version that has ever been read by the entire graph. And also it has causal consistency that needs to respect the Lamport's happens before relationship. This part, I did a diagram because it's kind of confusing. So basically, consider a function f, that is basically this one, that reads a version kv of key k. So this is the version that they are reading, and this is for each key. And we have v right here that denotes the set of key version that have been read previously by f or by any of f's ancestors in G, that is the graph. And we have also the dependency set, that is this one. For f at this point, that is, as you can see, it has all those that respect Lamport's happens before relationship for the version that has already been read by all other ancestors of f. And then the version key v that is read by f must satisfy this invariant. That is that kv shouldn't happen after any ki that is in the dependency set. That is that all dependencies must respect the happens before relationship and have occurred before current version read at key k. And this means that key v, KV is concurrent to or newer than any version of K in the dependency set B. This is very complicated. You can take a look and just like try to follow this one because it is kind of messy to follow this one along. And well, this is, as I was saying, this is the guarantees that they are talking about, but how do they implement this consistency? And to do this, as I was saying, they use the distributed session protocols and also LWW. That is something that Anna provides. Anna has these last writer wins lattices to resolve conflicts from concurrent updates. How does a lattice look like? It has the timestamp and then the value. And these ones are the ones that enable eventual consistency, because at the end, all replicas agree on the last written value that corresponds to the highest timestamp. And we can also improve on these lattices to get into causal consistency. And for this, we need to add a causal lattice. A causal lattice has a vector clock that identifies K's version. It also has the dependency set that tracks the key version that K depends on, and also the value. And vector clocks just have like the ID and the clock pairs. And whenever there's a merge, the causal lattice whose vector clock dominates is kept. And which one dominates? Basically, if all the entries of one, if we like compare two different vector clocks or two different causal lattices, if they have the same entries and one of those entries is greater than all of the other ones, then the one that dominates is the one that has the greater entry. But if they are concurrent, then we need to create another vector clock with a pair weight maximum and then merge the dependency sets via set union. And lastly, another of the important parts to implement consistency is the distributed session protocols. And we have one for repeatable read and another one for causal consistency. For the repeatable read, basically it means that it keeps a snapshot of whatever was read on the first time, and it stores this first version for the entire lifetime of the graph. And whenever a downstream function is executed down the graph, also the cache addresses and the versions are propagated into the downward or the downstream versions of the function. And the downstream executor must read then the same versions as the upstream executor. And when they have already read all of the versions of the upstream executors, then they notify like the very head so that the snapshots can get edited. This is the algorithm in which, well, basically is what I have just described, or this is the version that is shown in the paper. And also we have distributed session causal consistency. And this one needs the causal lattice encapsulation that I have just talking about in the LWW slide. And this one requires causal consistent store cache. And how is this implemented? This is implemented with the Bolton causal consistency protocol that ensures that each cache always holds a causal cut. We talked about these causal cuts, well, not specifically causal cuts, but we did talk about these cuts on this in the distributed systems course. But basically what it means is that there's a point in the middle, and if that point in the middle can basically consistently cut all the snapshots in the very same way. And for this to work, the executors again must ship the set of causal dependency to all of the downstream executors. Yep, this is the most important. This is the most difficult part of all of these like CloudBurst system, the causal consistency distributed session protocol. And if the algorithm doesn't look like that difficult, to be honest, is basically what I have just described, but they provide like an example in which there could be an error if it's not followed like correctly. In this case, for example, we have just imagine we have a graph in which we have these two functions, f and g, which are executed in sequence in different machines. And if we assume that f reads kv right here, and then there is a dependency right here that LU happens before KV. If the causal if the causal cut cache of the node executing in G, that is right here, is unaware of this constraint, then I mean, this constraint is on the valid versions of L, then G could read an old version of LW. And this starts violating consistency. So yeah, this is why it is so important to implement the session causal consistency protocol as expected. And at the end, they provide some evaluation and case studies to show that this works as expected. They say that the function composition outperforms commercial systems by 1 to 3 orders of magnitude. They even improve performance by 1 to 2 orders of magnitude. It has low latency communication, that these mechanisms allow like faster and better development, and also fast distributed algorithm with fine-grained communication. Its auto-scaling mechanisms are good at detecting and reacting to workload changes. And also, even though it has like tons of overhead to guarantee these non-trivial consistency models, the latencies are over an order of magnitude faster than DynamoDB and S3, while also providing stronger consistency. And also, well, since there are a lot of anomalies raised because of these non-trivial consistency models, they arose, of course, but the consistency model was able to detect them and prevent them. And also they create like 2 case studies, and this is like the conclusion. I'm not going to describe like them entirely, but they did a case study of a prediction serving and realized that the machine learning algorithm had smooth scaling and low predictable latency, comparable to other native outperforming purpose-built commercial service. And also they created this RedWiz, and they say that it was straightforward to adapt this standard social network application, and that their implementation added a modest overhead to server for Redis, and also that it scales smoothly as the workload started increasing. And yeah, that's basically it.
Yeah, I have a question.
Yeah.
Is this just a proof of concept, or they are already working on production, like on the industry?
The paper as it is right now,
Yeah.
at least is not available, and the
Okay.
paper is kind of new and is not cited in tons of places. So I do believe that this is not at production at all.
Okay, so this is more like a proof of concept, right?
Yeah, this is definitely. I mean, I may be wrong, right? But at least from the research that I made, it is still a proof of concept.
Yeah, because we can see that they are just like the good things that could be done with Cloudbuster. Or what is the name?
Yeah, Cloudburst.
Yeah, yeah, but there are no like bad things, right? There is no like this is not working, or this is not working as expected.
No.
Okay.
No, you know, they only take the benchmarks that they like. I mean, if they had some bad ones, they just don't publish them.
Yeah, but I mean, when they are doing that kind of evaluation, it's good to know that what is going good and what is not going that good.
Yeah, that you're 100% right, and this is not included in the paper.
Okay, thank you.
Yeah, I have also a question.
Yeah.
So, like when you started talking about function as service, that at the beginning I was like, probably like Lambda, you know, because that's recognized like function as a service. Also, the Azure and also Google Cloud has the same.
Yeah.
And what's the difference between those?
Between, do you mean like Lambda, any of those, and this one?
Yes.
Yeah. Okay. Well, the big main difference is that any of these Lambdas, I mean, any of these function as a service, don't keep state, right? I mean, whenever the Lambda stops doing whatever it's doing, the memory is released, and if you call that same Lambda again, you are delivered a different version of that Lambda that doesn't have any memory of it have been processing stuff before. And in this case, they say, okay, let's bring memory into these Lambdas. And to do this, they have like a global shared memory place that is a key value system. And to have these Lambdas quickly access this global key value system, they keep caches.
Okay.
That is basically seen just right here. I mean, if this was like a traditional Lambda, you could say this cache and this auto scaling key value store wouldn't appear.
Okay. Yeah, I was not sure that you didn't have cache. I think that was optional.
Yeah, no. This is like the core of it. It's not like really optional in this case. It's like the core
No,
of.
no, I
of
mean
the
like in the real services. I
yeah.
thought that actually you could share like some services and things like that.
Yeah, you can have it in layers, right? You can always have layers that do share memory. And also there is like in case of AWS, the temp part of the folder, it's always kept around for so many executions, but it is not at the level of these like global storage that is shared by all the serverless functions at the same time. And what is even more interesting is the function composition that they talk about, that is this, right? So this means that basically if you have, looking like, for example, at Python level, if you have a function that calls inside another function and another function, you can have each one of these functions being triggered at different places while also sharing the same memory.
Okay.
Are you done, Paul?
Yeah, I'm only trying to imagine exactly the benefits.
Okay. Rodrigo, what do you think should be the impact of imagining that this is going to be working in a good way? What would you think would be the impact of this in the industry?
I think that most of the times, I mean, they really talk about a lot about the disadvantages, like right here, that they have this high latency, these weak data consistency guarantees and stuff like that. I think this is a very important point, the weak data consistency guarantees, because many times whenever you are choosing between serverless and server aware, you do take a lot of care on consistency, right? I mean, and for example, whenever you want to make a bank application or something that is related to finance or stuff like that, they usually, the traditional way right now is going server aware and also having like very strong consistency guarantees. And whenever you are doing like a social network, you can have not that strong consistency guarantees or high availability. So in this case, if this manages to work correctly, then Lambdas or function as a service can be used for applications that require strong consistency guarantees, like banks.
Okay, because one of the things that I remember that I think the first paper that we read was about serverless, right, Madi? And I remember that they say that, for example, there are something like MapReduce cannot be done in serverless because they are stateful, and they really need the state for doing MapReduce. So I think that would be one of the implementations, right?
Yeah, that would fit just perfectly. I mean, that's like a perfect use case for that kind of applications. I mean,
okay.
While it is possible to have some stateful in a sense, like you can implement it in your way, it is not a native thing, and Cloudburst does bring it natively.
Okay, thank you.
Yes, I am the leader discussion. We are discussing already some of my questions, kind of, but another is that the paper does not mention many downsides of the technology. Could you identify any?
Well, I think that the most important one is like, I mean, they just like talk about all these distributed session protocols and also like the consistency guarantees and all the overhead that I have to go through. They use tons of very simple stuff that when added up come into something that is very complex.
Yeah, very complex mechanism. Yeah.
Yeah, because I mean, each one individually can be simple, but once you start adding them together, I mean, like if you go with last writer win latency, and then distributed session protocol, and then like the function composition with the DAG and stuff like that, you get lost. And that makes it very difficult for developers to really start learning and exploiting these kind of cases. I mean, the learning curve will be just terrible for people to start using this.
Yes. Another question is the main language is Python or Cloudburst, and Python is well known by being friendly to use, but also slow comparing to other languages. Cloudburst is looking for being a low latency solution. Wouldn't that be contradictory?
I think,
Using Python?
Yeah, I don't think so, right?
I
Because
think, well, yeah, go on.
when first of all, like Python 1, they are trying now to compile it, right? That's the first one. And the second one is that you have overhead in launching other things, you know, other systems. So I don't think that actually that overhead is bigger than triggering several times a super small function, especially with cache.
Yeah, I believe exactly the same as Paul. I mean that at the end, the overhead of setting the language all up and everything, it's not comparable to that of network, or even like making sacrifices whenever you have like a stateless system. I don't know, if you have a stateless system and you want to force it to keep state without modifying it, then you need to keep memory on your end, the client end, and that brings tons of overhead, because I mean, you need to set up all the database on your end and then like make the transactions and then make a request again, and that simply duplicates everything. However, I mean, to be honest, I do think that they use Python because that's the language they know. I mean, I don't think that they really benchmarked it that much.
Yeah, maybe they mentioned in the page 4 that they use Python. There is no fundamental reason to choose Python. It's only commonly used, and that's all. Yes, and my last question is also regarding the past. Is Cloudburst is a technology to improve serverless computing, but what else is necessary to gain more momentum for this technology to really happen?
I think that for starters, they need like other 4 papers that talk like for better applications and benchmarking of this, right? They also need to be easier on, or probably like, I mean, probably Amazon has, or Azure or GCP has tons of these kind of guarantees, or the way around, that you really don't see, right? So if you really abstract them so much that it gets very easy for developers to exploit them, then you're on a good track. And lastly, I do think that they need to pair up with some cloud provider to make this easier for people to get. Because I mean, if they offer it like some stack that works over any other like serverless cloud service provider, then it might not pick up.
Yeah, maybe. Thank you.
Any other question? Okay, thank you, Rodrigo, for the presentation. I mean, the paper is, yeah, it's those type of paper you need to really read them like 2-3 times to fully get it right. And as you said, it's a new paper. So usually, I mean, the good thing is the academy is, okay, the paper comes, then there would be more paper coming, building on top of this or criticizing these papers or basically highlighting the weakness or things that maybe authors didn't really pay attention to the problem, or they just ignored it, or they just basically didn't discuss it, right? So the good thing is it probably in like 1, 2, 3 years, if you come back to this paper, you'll see it cited like 50 times. And then if you go read those papers or check them, then you'll see how they are looking at it, right? And that would be really interesting things to see. Anyway, thanks a lot, Rodrigo, for presentation, David, for managing the discussion. So we're done with the first 2 presentations. We can have a short break, and we can come back by 7:50 something, 52:03, to continue with the other parts. To have like a 5-6 minutes break, or we can come back 8 sharp. That's easier. Okay. So we come back 8 sharp and we continue with the other 2.
Thank you.
Okay,
Sounds
thank
good.
you.
Okay, thank you, Mari.
So next is Kauter. You can go ahead and share your screen.
Okay, thank you. Okay, can you see my presentation?
Yes.
Thank you. So let's continue with the third presentation of today. It is containerization technologies, taxonomies, applications, and challenges. Okay, let's quickly review the agenda. We are gonna through the next points is overview, container features, taxonomy, applications, performance metrics, and finally a conclusion. Well, starting with the overview, I would say this paper is about 40 pages with 113 references. It's most like a survey, and well, authors get information from sources like IEEE and ICM. I guess all you guys are familiar with these sources. And well, starting with the subject, containerization technology was proposed by IBM in the last century. And this was the beginning for the process of isolation. The paper do not state it, but I guess in that time they were trying to run multiple processes with just one equipment or just one operating system. But what are containers? Well, containers are a lightweight operating system within the host operating systems that runs it. Well, I would say it's they are operating systems inside another operating system. Sounds like a tricky, but well, let's continue with the presentation so I can explain better this concept. And well, in order to do that, I would ask why we're with containers, why we have this technology. And this is because nowadays we have a requirement to solve complex problems in a short term of time. And well, in order to solve these complex problems, we have to install or to use complex systems. I mean, IT systems and virtualization let us know, well, allows us to reduce this complexity. And well, but these 2 concepts, containers and virtualization, allow the systems to get more flexible, and also they improve what is scalability and the fault tolerance and also the high availability. Also in the paper, it is stated that in some cases, some of the papers or the references talks about that there is issues in performance and also orchestration and security. But also it states that these kind of issues are kind of old, because from about 2013, containers get some improvement. So these issues would be in the past, basically. And well, virtualization, that is a technique to reduce complexity, has two options nowadays. One is the virtual machines, and the other one is the container. As you can see in this chart, the one for the containers is shorter because there are no operating systems in where are the containers. And difference with the virtual machines, we have a host operating system, and also we have more operating systems in the virtual machine. Also, as you can see, this is an advantage, because since there is no operating system per se, in the container option, when you start or boot a container, the process is faster than in the virtual machine. But this is because with the containerization, with the container alternative, it abstracts the operating systems instead virtualizing hardware. And also this the container option increases the capacity of the development of the developer, sorry, for the redundancy. And well, starting with the containerization technologies, we have three main technologies mentioned by the paper. This is Docker, Singularity, and uDocker. We have here the comparison chart. I guess the main or principal question that surges down here is that which is the best one? Well, in this case, I would say the best one is the one that provides you the way in order to reach your objective. As you can see in the first line, we have the Docker that has been adopted by the enterprise sector, and Singularity and uDocker, they are mainly for the scientific development. And also another concept that is pretty mentioned in almost all of the paper is the isolation. This concept has to be with the independency of our process running in the container, or independently from other processes at the same time. This is one of the features that provides the containerization. Another pretty interesting point is that Docker, Singularity, and uDocker, and mainly all the technologies that has to be with containers, are based in Linux. Since the beginning, in the middle, and at the end of the paper, it says that Linux is the base of the containers development. Sorry. Okay. Container features. I guess this is the most important part of the paper, at least for me, because I am not an IT guy. So reading and understanding this allows to me to understand better what is containerization and how it works. And in this part of the paper, we have three concepts that are pretty important. The first one is microservices. this a program, but with an opposite point of view from the past, that is monolithic architecture that refers to have a just one source of the program, a big amount of code, and microservices are the, I guess, for say or name them in one way, it's microservices are a program, or better said, microservices are the parts of a program that take is like a puzzle, and also they need to communicate because they are parts. Microservices are part of a program, and they need to communicate among them. And how is this communications be performed is because of the REST APIs. Because of this is how the microservices communicate among them. And with these concepts, microservices and REST APIs, we have parallelization functionalities, and this enable high-speed distributed processing. So this means with containers optimize the usage of the infrastructure, the flexibility, and well, the capacity of perform large activities in a short term of time. And also in this chart, you can see how is the architecture in a common uses of the container. There are various layers that has to be or need to be used in order to perform what is containerization. It's a pretty well, it's a pretty good abstraction of what is architecture based on containers. Also, the second and the third feature of containers are lifecycle and orchestration. In the lifecycle, well, I guess we have reviewed them in previous presentations, so I'm gonna be too short to present this. Well, mainly we have the states of a container. Once it is created, the container has the states running or maybe be paused or stopped, and after that it's gonna be calculated. These are the states. But what this provides or the contribution of this easy or simple life cycle is that it provides major benefits when you are programming or developing microservices because of the test, the development, and also it's easier for it's easier for the developers to use them instead using virtual machines. Also, also a pretty important part of the paper is the orchestration. This layer has to be with the applications and also maintain service level agreements. Here I am provide a list with the main orchestration technologies, and I guess the most well known is Kubernetes. Also, we have Swarm for Dockers or Apache Mesos and Nextflow. That's, I guess, well, those are the main or the most well-known technologies. And as I said, Kubernetes is I guess, is the most well-known. Also, we have down here comparison table, and also, well, we have we can see that Kubernetes maybe is the most well-known, and because of the technologies that they can handle, Docker, CRI, it's the most well-known and the most I guess also the most important container orchestrator in the market. And also, it, as you know, it is free, of course, free as a container orchestrator. Well, also Swarm, Mesos, and Explore as well. The next slide has to be with the taxonomy. In the paper, the authors talks about the proposal of some reference they get, and I just listed them because I tried to get the references, but for some reason I couldn't access to them, so I listed them. We have 3 authors that are proposing taxonomies, and they are propose them in function of I guess a point that maybe is the most important for them. The first one is has to be with the structure. The second is about, or has to be with the technology foundations. And well, this one, the red one, is the proposed in the paper. What I said is that this proposal has to be mainly with users. What I mean with say they has to be with the users. At this point in the down, it has we have a computing infrastructure. Someone has to administrate that infrastructure. Also, we have the orchestration layer. Here we have an administrator, also moving or working with the creation and administration of the containers. And in the top of the chart, we have the application layer that has to be with the users. I would say that this proposal has to be with the users of the containers. And more at the right side, we can see the decomposition or the proposal of the particular points of what matters more to those users. I mean the orchestrator administrator or the infrastructure administrator. So I guess this the most important point of this proposal is that has to be with the user. In difference with the proposed in other papers, that has to be with technology or maybe with infrastructure or what the authors consider the most important. Okay, the next slide, we have the applications. Or saying other words, for what is working the containers. Here we have the list, but instead going one by one and explaining what has to be or what is each one, I would present a little video of maybe it's a case of usage from an enterprise. Who is selling this? Who is selling a solution that includes Kubernetes. Let me show you, and I will share it with you. It's a pretty short. It is 2.5 minutes long. So let me show you, and I will continue after the video ends.
Containers are gaining momentum across all industries, providing speed, agility, and cost savings to cloud-native applications. Yet, with the vast majority of applications still on premises, how do you gain the benefits of containers for non-cloud native applications in your own environment? HPE GreenLake delivers the industry's first enterprise-grade, scalable container platform with 100% open source Kubernetes for cloud native and non-cloud native applications to your edges, co-locations, and data centers. All accessible through one portal called HPE GreenLake Central.
GreenLake Central is really the hub of activity for our GreenLake customers. It's where GreenLake customers can go to see their monthly charges, understand capacity planning for their GreenLake environment, and do more detailed cost analysis for any GreenLake services that they're consuming. In addition, customers that consume our platform or as-a-service solutions use GreenLake Central as their centralized point to be able to understand, view, and manage those solutions. For example, let's take a look at our GreenLake for Containers environment. This is an orchestrated Kubernetes container environment, and if I want to do something like create a new cluster, I've got very simple one-click access to be able to do that. I just give my cluster a name, select a site if I've got more than one site, pick which size of environment I want to create based on a blueprint, and the automation takes place to build that environment in the background. Once my clusters are up and running, I have very simple point and click access to the clusters to be able to manage them, create namespaces, control access to those namespaces, and pass that on to my developers so they can start to push their containerized code up to this Kubernetes environment.
HPE GreenLake makes it easy for enterprises to utilize containerization, from ease of use to cost-effective economics. HPE GreenLake delivers reduced complexity with a pre-integrated infrastructure managed for you and a unified control plane for cloud-native and non-cloud-native apps. Plus, end-to-end security with enterprise-grade security and authentication services. And all of this is consumption-based, which reduces expenses by eliminating upfront costs and only paying for what you use. HPE GreenLake helps eliminate the risks of emerging technology while delivering all the benefits. How could your company utilize the growing adoption of cloud-native applications when it's as easy as this? Learn more today.
Okay. Did you hear that? I short the sound, but don't know
Yeah, it
if...
was good.
Okay, thank you. Well, let's continue. Performance metrics. As any tool, you need to measure the performance. And well, when I was reading the paper, what I was thinking is how they measure the performance of the CPU throughput. And well, I went to a reference paper, and it said that this measure is through install microservices of what you wanna measure. In this case, LINPACK is used to measure the CPU testing, and Stream is for the memory throughput, and Bonnie++ is to measure the disk and input-output resources. Also, we have isolation performance. Here, the author said that this is performed comparing the baseline container running one microservice, and this is used to measure against a container running maybe a lot of microservices, or a lot of containers running a lot of microservices. Those kinds of performance are compared with this baseline. And finally, the network performance is measured with a tool named iPerf. And finally, we have the conclusion on future network. And well, in this paper, we define the feature, also some taxonomies. The architecture was described, and well, we also talk about the uses of containers. And the future, and for the future work, we have unique kernels. Unique kernels, well, looks like improved containers, but with the better security and performance. Okay, well, that's it from my side. Sorry, guys, I was kind of running because I was thinking we have just 3 presentations, but now we have 4. So I wanna give some time for the last partner. So, well, do you have any questions?
No worry, Gautier, no worries. Thanks for the presentation. Questions, Juan Cuellar.
Hello, everyone. Yeah, I saw that we
Hello,
have
Juan.
today four presentations. That is why it was so quick. Okay, yeah, this paper was really large, 38 pages, as far as I remember. Quite long and with a lot of technical data and information. But for this discussion, I wanted to make like some kind of twist of it. So for the first 2 questions, I wanted to focus on something else more extensive that actually involves the whole paper. We know that computer science has a huge amount of topics. We have to learn all of them, well, or at least the ones that we needed. And in previous papers, and one of them was one of my presentations, they speak about taxonomies. And as we remember what it is, it's actually the science of categorization and classification in hierarchical order, mostly. So the first question that I want to ask you is, why in computer science and in specific in this kind of technologies for cloud computing, containers, virtual machines, why is it important to make taxonomies? Why do you think it is important? That is my first question. So,
well, that is like in a real life. We need a taxonomy for everything.
Yeah.
In real life, in other science, there are the taxonomy part. So I don't get it. Sorry.
Well, from my point of view, a taxonomy is important because as in my case, I need to know this path, like a path of or classifications of what its containers. I mean, the taxonomies provide a chart where you can see about what you need to think about, what you need to research. I mean, more or less when you are buying a car, you maybe you have a you wanna buy a SUV. Well, you need this kind of taxonomy going brand by brand, which SUVs has each one, so you can have an idea which is the best or which one are you going to compare. I guess it's the same in this taxonomy of containers. It gives you in one shot the idea of how big is this subject.
I think like Rodrigo said in the chat, even in when you are doing a program or a system, you need to keep some kind of order in the thing, so it's better to process that information. So in the same way, we need taxonomy, so it's easier for us to understand what is happening with something, or it's better for the brain to comprehend what is happening.
You said something pretty interesting. Process information. I guess the taxonomy or this chart is the first step in order to, as you said, process information. You have all this scope, and after that you can start to processing.
Well, that is right, but we have different points of view about how we can do those categorizations. And taxonomy speaks about specifically in hierarchical order. So it must be in some kind of order of importance, which lead us to the second question, which is, how do you think the authors pick up the topics to arrange them? I don't know. Maybe, for example, capacity in the specific case, for example, capacity of the containers or special features that they have, or containers versus virtual machines. So what do you think about it? So because several authors have different kinds of taxonomies and how to arrange them.
Well, I could say the authors or someone can propose a taxonomy based on what matters to this person. I guess if for this person, what is important is the colors. They are gonna classify against colors. If the important of the, or if they think what is important is the weight of something, they are gonna classify in that order. In this case, I noticed that the proposed classification I noticed that the proposed taxonomy in the paper, it was, or it has to be with the persons who are administrating the infrastructure, the containers, or the end users. I guess for the authors, what are important in order to propose this taxonomy is the people, or the administrators, or the customers that are consuming those containers.
That's good.
I also I want to share the perspective of academicians. Okay, not the practitioner. So I mean, we do that actually. It's a very common practice in academia. There are tons of information out there, right, about any particular topic that you can imagine. There are so many papers, so many ideas. So as they mentioned, it's a way to basically just categorization of the brain, basically organizing your ideas as Rodrigo put. And another thing is like bringing us, simplifying basically everything that is out there for newcomers, for people that they are just coming to this area and they are just going to start researching about the topic, understanding about the topic. It's like, okay, I'm gonna go look at all the literature, okay, at least those that I feel they're important, then I'm going to summarize them, try to simplify everything, summarize everything. So when you come then in 2 years, when you come to this area and you want to study this, so you can just go directly read this paper and get a broad perspective of the area. So these papers are actually, they're valuable in this context as well, you know, to give that broad perspective for someone that is not so familiar with.
Yeah.
Right. Right. It helps to be familiar with the subject or the matter.
Right. Well, now that we spoke about a little bit about that, now there is another important stuff. I know that containers use less resources than virtual machines, so they offer better capacity in order to run applications and develop some kind of software. But do you think in the future, actually there is some future research about something better than this kind of technologies? But in your point of view, do you think, just your only point of view, can you imagine something better than containers or a concept that could be different, that actually will be better? That is the question.
Yeah. It should be a lot of investigation about infrastructure or how to improve the infrastructure performance. So yeah, definitely something is gonna arrive, and maybe it will be more or less like containers, or maybe by virtual machines, or maybe it's gonna be a completely different paradigm, but with the purpose to improve this infrastructure performance, flexibility, and also, well, I think every day, every time, someone is trying to improve the performance of everything. I mean, the life, the uses of infrastructure, or maybe a selling process or whatever. So I guess this matter, or this subject about infrastructure infrastructure usage is going to be improved, making better containers, or as I said, bringing something completely new. And well, just to in my comment, I would say, yeah, we have this unikernels that is a proposal, or is a mentioned by the authors in the future work, and it seems like it's gonna be an improved container. It would be maybe it's gonna be that, but maybe it's gonna be something else.
Okay, there's something that Roland is saying about, rather than starting with everything, but with bare minimum and not dependencies on as needed based. Yeah, it's if this was a really long paper. Now big IT companies are using containers, so it is important to standardize tools in order to use them. Listen, sorry, I'm having problems with my throat at this moment. Also develop good environments. In this way, there could be scalable structures. It's possible to build scalable structures based on microservices. And as you say, Gautier, the future research goes focused on minimalistic operating systems like unikernels. And I think we really wrap everything out. If anyone have another comment or question?
Yes.
Okay.
That's it.
Okay.
We were done here. Thank you.
Thank you, Gautier. Thank you, Juan, for handling. So let's go with the last presentation. I think it's Jose Laza. Yeah.
Yeah, let me share.
Just before you start, I wanted to ask everyone that so far they presented in the second part, please upload your presentation file in the spreadsheet, so everyone can have access to that for those people that they already presented actually. So I made a space for you to upload the presentation that you did in previous classes. Yeah, go ahead.
Okay, thanks. My paper name is Game Theoretic Modeling of DDoS Attacks in Cloud Computing. So what does this paper problem needs to solve? Basically, it's like you have in cloud computing different how do you say, different enterprises which are sharing the same machine, right? So right now the paper says that you have like these two enterprises, which one is bystander, which has nothing to do with the target enterprise, and the target enterprise, right? They both share resources, and there's a criminal who wants to do the most damage to the target resources, to the target enterprise. The question here is, who should he attack to produce the most losses to the target enterprise on one of their big sales? This is like on their annual sales event. This could be like Amazon Prime, or I don't know, Prime Day, or Buen Fin, or whatever, right? And also the cloud providers wants to minimize loss during this attack. What should it do to minimize these losses? There's a question that should it remain unbiased? Like, should it be like, no matter who's attacking, should I just let them go through? Or maybe if I have some service level agreement that I should give them more resources, and I'm going to get more losses from if they get attacked a certain company, maybe I should give them more like bandwidth, CPUs, more VMs, and so. This kind of the problem that this paper tries to solve. And yeah, at the end is, who should it protect more? The one that's paying him more, or the one that's using more resources, or what? Right? First, what's a DDoS? It's a distributed denial of service. And how can this be done? It can be done by two different methods. One is network level flooding attack, which exhausts cloud routers processing, network bandwidth, or other network resources, basically attacking the network. And second, application level attack, which exhausts server resources such as CPU, memory, disk, or I/O bandwidth. There are some examples for this, like HTTP flood or DNS flood. Then here we have like some customers using their machines, trying to get into the cloud, and everything goes all right. But then we have like this attacker, which has lots of bots attacking the same, right? So basically, this is the system that we are going to study and to give like a fix for this issue. The important thing that DDoS does in the cloud is that when you attack one tenant, it will affect others because they are sharing resources. So let's keep this in mind. The background in the paper is why does it affect DDoS attacks in cloud? What happens? Well, why does it affect? Because the more request comes from bots or from the attacker, there's the need to allocate more resources to defeat that denial of service. And if you are allocating more and more resources, it's costing you more to do like the same for the client, right? And what happens when there's not enough resources to defeat this DDoS? Actually, there's a case on the paper which says that AWS suffered this attack, a DDoS attack in 2019 that resulted in outages for customers up to 8 hours. So imagine big customers having, well, can't accessing their service for 8 hours. It's like lots of losses for the enterprise, right? And more if they are done like on the they have more sales. So this is really important. And also the dynamic allocation strategy is not always the best for DDoS. It can sometimes make it worse. Like the attacker is just flooding you with requests and you're trying to allocate more and more and more and more resources. And then you will end up having non-resources for anyone, not just the service that is attacked, but for any other user that's using your cloud. So also it says something interesting where it says like high-profile consumers with more to lose in public cloud should invest more in security than smaller cloud consumers, right? Because if you're a small cloud consumer, it will not affect you the same having your service down for a couple of hours than if you are Amazon or Google. What are the defenses against this kind of attacks? Well, they are done through mitigation. One is filtering. Some filtering defenses can defend you up to 75% of accuracy. So only one of each 4 requests will go through from the attacker, right? Another mitigation is rate limiting. The one downside of this is it will discard also legitimate requests from the users, but at least you will have your service up and running. And the last one is service cloning, which is the elasticity in cloud. Just provide more and more and more VMs, so you can reply back all the requests, right? What is the game modeling in this paper, right? We model this DDoS like non-comparative because both the attacker and the defender wants two things different. It's simultaneous because it's happening like in real time. It's a non-zero sum game. It only involves 2 players, the attacker and the cloud service provider. The user right now it's not involved, and both will have complete information regarding what the other is doing. All the structured possible moves and payoffs for all outcomes. So this is normally not viable, but let's presume we can do this. And the attacker wants to inflict maximum economic losses over the service I or enterprise I. And the cloud service provider wants to minimize the losses from his SLA, right? Now we are going to see what's the attacker strategy. It could be only 2, like attack the user 1, which is the bystander, or attack that the attacker can do. And we will assume that the attacker has at least the same amount of computing resources as the cloud service provider by using bots. Also, we won't do like a mix-up of attacking with some requests to the bystander and some to the target. We will only choose one or the other. The defense strategy is also only two things. You can do the static strategy, which is like limiting the rate of traffic, and the dynamic strategy, which is elasticity, start getting more and more resources. What happened to filtering? Well, the effectiveness of the defensive measures for filtering are discarded, because if the defense can filter like 50% of the requests, then the only thing that the attacker needs to do is to send twice the request, and it will be the same, right? So we don't need to take this into account. Now, for the game theory, to make this more like clear, I need to explain what's the Nash equilibrium, or maybe if you all know, we can pass this like slide. Okay, I guess I'll explain. Here it's one of the most common ways to explain this Nash equilibrium. It's like there are two prisoners, and they will like interview them, but they cannot talk between them. So there's only two choices: to lie or to confess. And what they want is to have the best possible outcome, right? So let's say if the prisoner 1 lies and the prisoner 2 confess, then the prisoner 1 will get 10, which is the maximum for this game, but the prisoner 2 will get 0, right? So for prisoner 1, it's good to lie, but for prisoner 2 confess, it's not good. Then if prisoner 2 does the same, lie and prisoner 1 confess, well, it's just the other way around with the values, right? But if they both confess or if they both lie, then it will have like 6-6 or 1-1, right? What the Nash equilibrium says is that if you know what the other is going to play, you can always have like an equilibrium and not and have like the best outcome for both. Like in this case, you will prefer to have a 1 than to have a 0, right? For both cases. So the Nash equilibrium will be to both prisoners confess, and they will have 1. Or another one, if you know that the other prisoner is going to lie, it's easier of 6-6, more or less. Okay. Now this is the hard part of the paper, the modeling of the DDoS in the cloud. There's like lots of numbers and formulas. These are the descriptions. You don't need to care about this. We'll have the right numbers just in a moment, but just so you know that there are some formulas where all these numbers were taken. The game analysis is for the cloud provider for the defense. First, we will check if it's unbiased, which is like giving the same services to all the enterprises, no matter what. Here we have like the demands for enterprise I will be like the target target enterprise, J will be the bystander, and A, it's the demands for the attacker. Like the attacker will put 70% of all the requests, right? And here it's the payoff. How much will they lose? Here it for the defense, it's a percentage, like 3% of the requests are getting dropped, or 20% of the requests are getting dropped, right? So it needs to get less numbers. So basically, if you check for the defense, if you will go into dynamic or static, that's meaning of S or D. If you check the numbers, it always is better to go to the static because it's less packages drop than the dynamic. And knowing that, the attacker will go through AI, right? So the Nash equilibrium for this unbiased is AI-DS. Okay. Now for the bias way is different. The weight, like right, the payoff. First, we will have a bias of 1.20 and 30, or 30 and 20. It's the way around. So if you check in both cases, the defense will always go static because it's less packet drops than dynamic. But for the other way around, for B having more, in this case, like I is 10 and J is 40, then I will drop only 1.43, right? So it's okay. And in this case, it will drop 16, but here it will drop 15. So for the defense, B equal or greater than 4, it's better to go into the dynamic because 15 is less than 16, right? And if this goes more and more and more, then this gets greater than these values. So you lose less packages by going into dynamic than into static. Now we put into the shoes of the attacker. The biased is, if you see here, this AI will be greater than AJ, and this is the same. So it's AI, and the other doesn't care, right? DS or DD, it doesn't matter, at least for the analysis of the attacker. Then the defender payoff with biased and unbiased. Here we have like understanding the previous strategy that AI will always, the attacker will always go into the I, which is the target enterprise. We have like this bias for the other and bias for our target, right? Here, the attacker will go through IA, but the defender will go into static because this is less than the right side. As long as BI is less than 4, right? If you see the the first and the third is better the left side than the right side. But in the case of vi equals to 4, oh, sorry, then you start seeing this value greater than the right side. So you will go into the right side, DD, when B is greater than 4. The conclusions are that the bystander and target share resources from the same cloud provider. This is the same slide at the beginning. So the criminal who should he attack, it's the target, BI, what we saw, and the cloud provider to minimize losses during the service. What should it do? It says it starts to be biased by 4 to prevent paying them more due to losses, and then when he sees that the losses are getting more and more and more because the load is increasing, like the load is increasing, then went to the dynamic to find like this Nash equilibrium. And conclusions, we as users, what can we do? Just securing with our service, with our cloud providers, the high traffic priority through SLA. So they would, if we are target through some attacker, they will lose more money if they get bias against us. And choosing a fair service provider. What are the limitations of this paper? That not in the real life, not both players have the full information. That you cannot consider what the other player will do to maximize their payoff. That DDoS can be subtle and carry amongst lots of time without the cloud service provider knowledge. That they can start injecting you like requests with passing them by authenticate, and then the cloud service provider will never know that those requests were from an attacker. And when the attack goes through lots of time, it will just like evade the mitigation. And that this game is asynchronous, right? You don't wait for the other to do their move so you can do your move. So this implies that you can make in the defense or the attacker, it can move quickly between one or the other strategy. Thanks.
Thank you.
Any
Sorry.
questions?
Thank you, Jose. Was complicated for me. The result part, I mean, without going through understanding the equation, understanding the result was difficult. But yeah, first question, I mean, just very simple. Like, you think it's, I mean, DDoS attacks have been around for a long time, right? I mean, long time. Yeah, modern history, actually, not ancient things. But I mean, before cloud. So is there any difference in our approach to DDoS on clouds or on non-cloud technologies or sites or?
I don't get, like, is there anything approach to carry on the DDoS attacks?
No, to protect. I mean, because I mean the DDoS attacks are older than cloud technology, right? Let's say, and we have certain solutions for DDoS attacks on traditional basis. Isn't anything special about cloud that make it difficult, more difficult, or what do you think?
I think they are more like exposed because
exposed. Mm-hmm.
Yeah, because normally like if you are nobody with an enterprise and have a little server on your, let's say, on your room, and you have there your enterprise and everything and your service, well, it's harder to get into that server and do a DDoS because no one knows you, right? And probably no one even cares to do that DDoS. But now that we have like these cloud service providers, which are really big and noisy, maybe there are more like hackers or attackers that wants to do damage to those like services, right? So that's what I think. Like, since they have like these huge machines and services, I think they are more attacked, like with cities. I mean, with banks, right? With Citibanamex and all of those banks. Like the biggest bank here in Mexico is the one that gets more attacked, just because it's bigger, not because it's safer or not.
Okay.
I don't know if anyone else has another opinion.
I have seen some websites that has an intermediate step between logging, accessing the website and you putting the web address in the URL space, and it says like kind of authentication against the denial of service attacks. I don't know exactly how they work, but it seems I'm curious about it.
Yeah, but let's say that service is down because I send that service like 1 trillion requests per second to authenticate, right? Through lots of bots. So that's the issue, right? You cannot pass the first like or an HTTPS or DNS flood.
But you have certainty in that, because if you're correct, so that's a waste of a protection there.
But it takes down that service, right? And if you have that service in the same machine that you have your application, then it will start doing wrong things, right? It will start to consume lots of CPUs, lots of memory, and it will affect your station. And also, from the paper, it says like they start like doing eardropping and get some like requests, signatures and stuff like that, and passing it
captchas.
Like, well, not actually captchas, like your traffic, like resending messages through the network, right? Which were previously authenticated, so they can pass like, okay, an issue with TCP that it went through another route and it's getting just later or something like that, and they will bypass that authentication service.
Okay, Culture, you have you prepared questions or?
Yeah, I have some questions about this paper. And well, at the beginning, it references about attacks to Amazon, real attacks, and well, it states that there was no service for about 8 hours. Imagine a big company as Amazon being down for 8 hours. Oh, well, it's a huge damage. And well, after reading this paper, I know there are persons / enterprises with the power to attack a cloud provider, such as Amazon or Google. How much do you trust into contract this kind of service suppose you are the owner of a company.
Whenever I have a client that goes into these types of concerns, I always say that if Amazon is down, there is something bigger that you need to worry about, right? I mean, it's like the internet is down. So, I mean, whenever you are over this type of very big platform and the platform goes down, then probably something more important there, whatever you are doing is down. So that is whatever I say to
Sure.
Yeah, but are you gonna could you contract this well after this review that Jose provided? Are you gonna trust in contract this kind of service, or you are gonna doubt at least a little bit to contract them? Because well, after reading this paper, you know that these service providers are could be a victim of attacks.
Yeah, I think one thing that sometimes when we are using the cloud services is that many times we think that we can be protected for everything if we manage to pay for everything, right? I mean, because as you start like paying for more stuff, you usually get better and better security. I mean, however, these kind of papers like the one that we just reviewed, I mean, getting Amazon down is no small feat. It really puts into place just what you were saying, right? I mean, not even them with all their resources were able to be safe from this kind of stuff. So yeah, I mean, but we can't be scared of everything.
Yeah.
Yeah.
You need to trust in someone or something.
Well, yeah, I think that's all we have right now.
Especially in the beginning, right?
Yeah.
Yeah.
Because actually it's going to be probably better your security than yours.
It's like going to be married. Okay, thank
Yeah.
you. I have a
Sorry. At least I think if you're connected to the internet, you're going to get attacked, right? There's no way that you can be protected for everything if you give access to attackers to by connecting to the internet. Like, I think
Yeah.
I have read that the only way to make your computer safe is like to put it on
Safe.
on a safe, yeah, on a closed
Without
room
a connection.
without
Inside of a
connection.
microwave.
Well, having a computer.
Basically, you have to put
Faraday
it
cage, right?
Faraday cage, right? So you don't get signal.
Yeah, you can always put it inside of the microwave. Just leave it there for 1 minute or so. I mean, then you're good to go.
Or you can do everything on paper.
Not all microwaves are Faraday cage. You can do
You're right. Yeah, I mean, there's always some way to destroy it.
Yeah. It's true.
Okay, thank you. Well, let's move to the second question. And well, from your knowledge / perspective, what is theory of games and Nash equilibrium? I am asking this because this subject, theory of games, has to be more with industrial engineering. When I was studying, I remember this subject was included in some books. I don't remember which is exactly one, but one it was operations research, or maybe it was in design of experiments. These subjects are from the industrial engineering area, and well, I was surprised to find this in computer science. So most of you all guys, you has to be with the programming area. So I would like to know if you have heard before about theory of games or maybe about the Nash equilibrium.
Yeah, actually, game of theory, game theory, it's a part of mathematics actually.
Yep.
So actually, it's related to so many industries. It's not only like industrial computer science. It's in a lot of things actually, and it's on the logic part.
Yeah, it has to be with statistics. Well,
Yeah.
since my point of view, and well, you know, statistics has to be with a lot of things. But I was surprised to find this in this area. Yeah.
Yeah, it has used in every possible field that you can imagine. Game theory is now using, especially even in economy. That's like I find it interesting always. So yeah, they use it a lot, the game theory.
Okay, someone else would like to express their experience with a game of what is this theory of games. It is new for you, or have you heard about this before?
Kind of new.
On the movie, right? I'm not sure how it's named, but it is like from this Nash when it discovers the Nash equilibrium. I'm not sure if it's like a brilliant mind or something like that, right?
Yeah, with Russell Crowe.
Yeah, now you got my attention. Okay, yeah, I don't remember that movie.
Beautiful Mind, yeah, that's the one.
Yeah, that's right. I didn't know that it was from there.
Yeah, it's about Nash.
Yeah, that's when I heard that, and I actually started reading some of game theory due to that.
Okay, any other questions, comments about the paper? Security.
Well, I have the last one.
Sure, go ahead.
Yeah, well, give your feedback regarding the following statement in the paper. The attacker uses its nodes access behaviors of legitimate users to generate legitimate HTTP GET requests in excessive volumes to overwhelm the cloud resources. Why I'm asking for your feedback about this, because when I read about an attacker use legitimate users or legitimate whatever, I was pretty scared, because anytime I hear about hacking attacks, everything, it's more, or it has to be more with a treat, or try to a treat, maybe a sniffer, or try to I don't remember the exact words in English. I would say in Spanish, engañar to the system. Well, this is the first time I read about an attacker use legitimate whatever, and I was scared. How do you protect about this? Jose Antonio told us about one way to protect about this, but what do you think about attackers using legitimate ways to get into your system or into your computer?
I don't understand correctly, but if they are getting into your system, it's not legitimate, right? It's always against the rules. So, but if you are doing it like in a smart way, like that's like so, or not social, like how you say? I think it's called
social engineering.
Yeah, something like that. That those are only other ways, right? That it's not like a, let's say, computer science way, but it's more like social skills or life skills, right? That you are applying into that.
Yeah, let me put it this way. When I hear about attacks, I am thinking about a guy trying to get into a house. It uses a window or maybe breaks the door, or whatever. I am thinking about that. But after reading this paper, I get this concern because an attacker can go into your house just opening the door as if he had a key. That's what I mean with legitimate attack, or using a legitimate way to get into your house. They are not breaking nothing. They are not trying to jump. They just go right into the door with a key. That's I am trying to express. I get scared because I am thinking my computer is secure because I have an antivirus or maybe I have a firewall, but these barriers can be jumped because someone is emulating a legitimate way to get into the systems. And in this case, and in this paper case, they are overwhelming or overflowing the systems, sending this attack as a legitimate way of request. I don't know if you can. Well, I don't know if I express in a correct way this idea.
Yeah, the idea with the DDoS attack or distributed denial of service attacks are basically making the system down due to heavy traffic load. So actually the idea is they use valid packets and basically legitimate traffic, because if the traffic is suspicious, it can be easily detected, it can be easily filtered. So it never happened actually. So the traffic is usually, or most of the time, is legitimate. For example, for example, they attack by, I don't know, DNS servers, domain name servers. They request for information from certain sites. The request is valid. So DNS server have to basically ping you with with a lot of information, asking them. So, I mean, the traffic is always legitimate for, not always, I don't want to say always, then you'll find something illegitimate and you say, oh, it's not always like that. But most of the time, the traffic is legitimate because it shouldn't be detected. The traffic should be legitimate, so it shouldn't be detected, it shouldn't be filtered. So for DDoS attacks, that's the case. But it's not such a big concern for average users, DDoS attacks, because it's majority is for a big organization, for a big, how to say, big entities usually. I mean, that the DDoS attack can start or initiate other type of attacks. Okay, it's not just, okay, so the system is down for 1 hour, so not a big deal, but that can initiate attacks for more complicated things after they make the system down.
Right. Yeah. That's like my concern. These legitimate attacks that can be detected or filtered.
Yeah. Well, I also heard. I think we all heard like the attack against the Sedena, like a couple of weeks ago, and they said like, hey, we weren't the only ones there getting all this information from the Sedena like from months ago. So if there are different groups that can attack successfully the Sedena, well, the average user will be always like a target, right? But it's not like our lives are so interesting that a group wants to hack you. At least that's what I think.
So those type of
And if
attacks,
they want, I can give them my information for free.
they
Yeah,
call those
so
type of
don't
attacks
don't
are
bother.
advanced persistent attacks, and usually they are for high valuable targets because the attacks is really advanced, and it's usually they go low and slow so they don't be detected, and they have presence for many months or years without being detected. So I mean, those are for different type of this high valuable organization or people. But I mean, anyway, those even the small information that we have are valuable. Still, don't give it away. It's that easy.
Okay, I guess that's it from my side. I don't know if someone else have more doubts or comments.
Okay, if not, so we can wrap up today's class. Thank you so much, Jose and Gautier, for presenting and leading the discussion. So please just include your presentation slide in the Google Sheet. It's not something urgent, but so everyone can have access to those if they want to go back, check your paper, look at the presentation. And yeah, that's it. I don't know if there is any question or doubt.
Yeah, can you make it wider, the columns for the questions in this spreadsheet? Like,
Yeah, sure. Yeah, sure. Okay.
they are really, yeah.
Okay. Yeah. Okay.
Thanks.
I already uploaded my suggestions for paper, so I present next week. So
Okay. Okay. Perfect. So take care, everyone. Have a nice night. I'll see you guys next week.
Thank you all.
Thank you, Maddie.
Thank you.
Thank you all.
Take care. Thank you.
Bye.
yes.
Bye. Bye.